Students, Sairam, this is Megha Miss here, and today we will continue with our revision part 2 of lesson number 1, gravitation. Okay students, as I told you in revision part 1, their important is about the Kepler's law. Okay, please study those law. Then the Newton, what inverse square law he gave, that you have to study. Okay, equations, you should know that all equations. Okay student, so today we will continue with this revision part 2. Okay, remaining lesson we will see. Now the next topic which you studied, that was Earth's gravitational acceleration. Now what is this students? Yes, we have seen that whatever the A value is there in the Newton's law, okay, what we take A as the the A value, okay, that is displaced by the G value, that is the gravity. A there is your acceleration in all the Newton's equation. Now they are replaced by the G, okay. See, the earth exerts gravitational force on objects near it. Yes, you know that. According to the Newton's second law of motion, a force acting on a body results in its acceleration. You know, when a force is acting on body, it will accelerate. Okay. Thus, the gravitational force due to the earth on the body results in its acceleration. So, here also, the gravitational force, it is responsible for the acceleration of the body. Okay. So, this is called as acceleration due to gravity, and we denote it by letter G, small g. Okay students, I hope it is clear. Okay, so now the value of G on the surface of the earth we are going to see. We can calculate the value of G by using Newton's universal law of gravitation for an object of mass m situated at a distance r from the center of the earth. Okay, mass, we are taking mass of an object as m, and the distance we are taking it as the r, small letter r. The law of gravitation gives, now you have studied the law of gravitation. Yes, you have seen this Newton's universal law of gravitation. What it is saying? F is equal to G m, capital M, small m upon r square. Okay, now here capital M is what student? It is the mass of the earth. Okay, also you have studied F is equal to M into G. Okay, yes, so from 3 and 4 what you can get, instead of F, you can see here, instead of this F I have put this mg. So see here, it became mg is equal to gm m upon r square. Okay, now students, this m and this m can get cancelled out from both the sides. So what equation you are getting? This equation 5. G is equal to gm upon r square. Okay, so if the object is situated on the surface of the earth, small r will be equal to the capital R. Okay, that is the radius of the earth. Okay, thus the value of G, yes, on the surface of the earth is, so we will see what's the value of G. Okay, so I hope till this part it is clear to you. If the object is at the surface of the earth, capital R will be equal to the small r, that is the radius of the earth. Okay students, so we'll proceed. See in the next part. See, G is equal to gm upon r square. So that small r I have now replaced with the capital R, which is the radius of the earth. Okay, so the unit of G in SI units is meter per second square. Okay students, the mass and radius of the earth are 6 into 10 raised to 24 kg and 6.4 into 10 raised to 6 meters respectively. These are the standard values, they do not change. So when I substitute these values in the sixth equation, which you can see, I am going to get the G value as 9.77 meter per second square. Yes students, you know G value you take 9.8, which is standard value. Most of the time you have taken while solving the sums. Yes, so this 9.77 also you can take, or you can round it off to 9.8. Okay students, standard values of the mass and the radius of the earth, I hope you have seen that also. Okay, it is already given, that is 6 into 10 raised to 24 kg is the mass, and 6.4 into 10 raised to 6 meter is the radius of the earth. Okay students, so this acceleration depends only on the mass and the radius of the earth. Okay, and so the acceleration due to gravity at a given point on the earth is same for all the objects. Okay, so you know now, you take a standard value G for any of the object which is on the earth. Okay students, at any point on the earth. So it does not depend on the properties of the object. It does not matter what the object is made up of, how it looks, what properties does it have. No, nothing depends on that. Acceleration due to gravity is only, it will be same at any point on the earth. That what we are taking it as 9.8. Okay, we'll proceed. Now the variations in the value of g, you have variations, right? The value of g varies based on the following. Along the surface of the earth, okay, the earth is not perfectly spherical, you know this. It is bulged at the equator and flattened at the poles, yes, due to its rotation. So elliptic you can say, okay. The radius is the highest at the equator and least at the poles. Okay, radius you will see at the equator is the highest, while when you go towards the pole it becomes less. So value of g is highest at the poles, that is 9.832 meter per second square, and value of g is least at the equator, that is 9.78 meter per second square. Okay students, you will remember these values and like this in points you can write. Okay, then next, change with height. As the height increases, value of g decreases. Okay students, the change is negligible for height smaller than the radius of the earth. So change, whatever the change of height is there, it is negligible for the height smaller than the radius of the earth. Okay, now change with the depth. As the depth increases, value of g decreases. Okay, this is because as we go inside the earth, the mass under consideration decreases. Hence value of g also decreases. Okay students, as the mass under, whatever the mass we are considering, it is very less. So the value of g also decreases. Okay, we will continue. The next topic students, you studied, that is about the mass. Now what is mass student? Mass is the amount of matter present in the object. Okay, simple words, what you will remember, it is the amount of the matter, okay, present in any of the object. The SI unit of mass is kg, this you know. Mass is a scalar quantity, its value is same everywhere. Okay, its value does not change even when we go to the another planet. According to the Newton's first law, it is the measure of the inertia of an body. Okay, according to the Newton's first law, you will say it is the measure of the inertia of an object. Higher the mass, higher is the inertia. Okay, inertia of state of rest it can be, or of motion it can be. Okay students, I hope till here it is clear to you what is mass. Simple, you will remember the definition, that it is the amount of matter present in an object. SI unit you will remember, it is kg, and just you have to remember that yes, mass is same everywhere. Even though you go on the another planet, it is going to be same. Only this many points are important to remember. Okay, next part is the weight. The weight of an object is defined as the force with which the earth attracts the object. Okay, it is the force with which it is pulling, okay, the object towards itself. The force on an object of mass m on the surface of the earth can be written using equation 4. We can write it as W is equal to F is equal to mg. Okay, and you know g is equal to gm upon r square. Weight being a force, the SI unit will be Newton. You know, for force the SI unit is Newton. Also the weight being a force, it is a vector quantity and its direction is towards the center of the earth. Of course the earth will pull everything towards its center. We have studied this. So weight also, it is directed towards the center. So the direction is also there and the value is also there. So we say that it is a vector quantity. Okay, the weight on the moon is nearly 1/6 of the weight on the earth. This you also have studied. We have used it in sums also. I hope you have solved the sums in your books. Okay, we can write the weight on moon as mgm. Gm is the acceleration due to gravity on the moon. Thus gm is 1/6 of the g on the earth. Okay, here also important to remember, W is equal to F, that is equal to force is equal to m into g. Okay students, weight is nothing but the force with which the earth attracts the object towards itself. Okay students, so these are some important points you will just remember. Don't mug it up everything. Okay, now the next part we are going to see, that is the free fall. Now what is this students, free fall? Whenever an object moves under the influence of the force of gravity alone, only the object is under the influence of gravity, we said that it is freely falling. Okay, thus the released stone is in a free fall. If I release a stone from a height, what it will be? It will be only under the influence of the gravity. Okay, you have studied this concept in 9th standard also. Please open the book and see again. First lesson only it is given free fall. Okay, in free fall the initial velocity of the object is 0. Okay, initial velocity will be 0 in free fall, and then it will go on increasing due to acceleration due to gravity of the earth. Because of the g value, acceleration due to gravity, then only the what will increase? The velocity will increase. Okay, for a freely falling object, the velocity on reaching the earth and the time taken for it can be calculated using the Newton's equations of motion. Okay, for a free fall, the initial velocity u is always 0, remember students, and acceleration a we replace by g. Okay, so see here you can see these equations how they change. First it was v is equal to u plus at. It changed to v is equal to gt. As you know, u value is 0. So I am not taking that. Okay. Next is s is equal to ut plus half at square. It has changed. In the free fall it is changing this equations. What it will happen? S is equal to half gt square. Because when u is equal to 0, 0 into t will be 0. Okay. Next third equation, v square is equal to u square plus 2as. So u square means 0 square it went. What you got only? V square is equal to 2gs. Okay students, it has changed to gs. Okay, I hope till here it is clear to you. Okay, so here a, wherever a acceleration is written, there it has been changed to acceleration due to gravity, that is g. Okay students, I hope till here it is clear to you. Okay, now we'll move to the next part. See here. Now the gravitational potential energy. Now the energy stored in an object because of its position or state is its potential energy. You have studied this also last year. Yes. This energy is relative and increases as we go to the greater heights. Potential energy will increase if you go to greater heights from the earth, from the surface of the earth, that is. Okay, we had assumed that the potential energy of an object of mass m at height h from the ground is mgh. You know, you have studied this. P is equal to m into g into h. This you have studied formula last year also. Yes, and if you see the potential energy on the ground, it is always we are taking it as 0. Okay students, I hope this you remember. Here only you have to remember P is equal to mgh. Okay, formula. On the next part, when h is small compared to the radius r of the earth. Now when h is very small, okay, compared to the radius of the earth, we can assume g to be constant and we can use the above formula. You have to take g constant. Okay, but for a larger values of h, the value of g decreases with the increase in height. G value, that is acceleration due to gravity, will decrease if it is going to a greater heights, right? Earth cannot pull it with that force. Okay, for an object at infinite distance from the earth, the value of G is 0. Okay, means it would not be able to pull that object with that force. Earth cannot do that. Okay, and the earth's gravitational force does not act on that object. Why? Because it has went a lot behind the influence of the earth. Okay, when an object is at height h from the surface of the earth, its potential energy is, how you give it, minus gmm upon r plus h. We take the height also. Okay, m and r are the earth's mass and radius respectively. So how you are going to calculate potential energy when the object is at a height h from the surface of the earth? You are going to use the formula minus gmm upon r plus h. Is it clear students? Did you understand till here? Okay, we will move to the next. The next topic we are going to study is the escape velocity. Now what is escape velocity? We have seen that, okay, we have seen that when a ball, yes, is thrown upwards, its velocity decreases because of the gravitation of the earth. Okay, when you are throwing upwards, what is happening? Velocity decreases slowly. The velocity becomes 0. After reaching a certain height, the ball's velocity will become 0, and after that the stone starts falling downward. Okay, we are taking an example of stone or a ball, anything. Its maximum height depends on its initial velocity. How much with the force you are throwing that ball, means from the surface it is going upward, that it will depend. The height will depend on that. Okay. According to the Newton's third equation of motion, you know now it has changed to v square is equal to u square plus 2as. So instead of a, what I will write? G. Okay. Now v is the final velocity of the ball. That will be 0. Okay. After reaching some height, okay, it will start its motion towards downward. Yes or no? A is equal to minus g. Why we are taking minus g? Because we are throwing it vertically upwards. Yes, not downward it is coming. So when it is coming downward, it is in the direction of gravity. When it is going upward, it is in the opposite direction of the gravity. So we are taking it as minus. Okay, so 0, whenever you see, whenever you are calculating something which is away from the earth's surface or not in the influence of gravity, we are going to take it negative. Okay, formula becomes negative. So 0 is equal to u square plus 2 into minus g, okay, into s. And the maximum height of the ball, s is equal to, when you solve it, what you are going to get, students? S. Okay, that is the displacement, that is the height in short. So s is equal to minus u square upon 2g. Okay, you see, you are getting the equation in negative because of the ball moving upward. Okay, or the stone moving upward, anything. So we have seen above that the value of g keeps decreasing as we go higher above the surface. Yes, we have seen when we are going higher and higher above the earth's surface, g value is decreasing. Thus the force pulling the ball downward decreases as the ball goes up. If it is going a lot up, force will decrease. Okay, if we keep increasing the initial velocity of the ball, if you throw it very speed, or you throw it with a larger speed, what will happen? It will reach larger and larger heights, and above a particular value of initial velocity of the body, the ball is able to overcome and the downward pull of the earth and can escape the earth forever. Ball can't do that, but it is an imaginary, student, that if you are throwing it a lot upwards with a very greater speed, the initial whatever the velocity you are throwing, it is very higher velocity. Okay, then what can happen? That particular object, it can overcome the earth's gravitational pull and it can go out of the pull and it will not come back on the earth. Okay, so this velocity we call it as the escape velocity. Okay, students, so what this velocity we call? An escape velocity. Escape velocity is nothing but that velocity with which an object is moved away from the earth's gravity and it reaches such a position that it can overcome the force of the gravity. Okay, students, I hope till here it is clear. Okay. So, an object going vertically upwards from the surface of the earth having an initial velocity equal to the escape velocity escapes the gravitational force of the earth. Okay, students, so if the object you are throwing it vertically upwards, so with a great speed, velocity, okay, who is having its initial velocity will be equal to the escape velocity. Escape velocity also some value is there. If that value is matching with the initial velocity, yes, there the object will be out of the hold of the gravity. Okay, the force of gravity being inversely proportional to the square of the distance becomes 0 only at infinite distance from the earth. So force of gravity, that is g value, can become 0, okay, in escape velocity. Okay, then this means that for an object to be free from the gravity on the earth, it has to reach infinite distance from the earth. Yes, if that particular object, it doesn't want the earth's gravitational pull to be acted on it, it has to move away to the infinite distance from the earth. Okay, students, you also saw the derivation here. Only we have to remember v escape, you have root 2g into r. Okay, for the earth you will remember the value of v escape, standard value 11.2 kilometer per second. Okay, students, I hope you understood what is escape velocity. Also, it is nothing but the speed, or you can say the velocity with what an object is thrown upwards to an infinite distance, to an infinite height, and that whenever it goes to that position, it can overcome the gravity pull of the earth, and hence it does not come back on the earth. Okay students, I hope today's part, whatever revision we have done, is clear to you. Please go through the video again and try to study this particular all the topics, important things what are there in this I have told you. Remember the formulas, remember the important points, don't mug up everything. Okay students, so we'll meet in the next presentation with the revision part of the next lesson. Okay students, thank you. Saira.